Now, last time we also started with this case of invertible systems, right? So we say that an LTI system is invertible only if there exists an inverse system such that the concatenation of the original system and its inverse system gives you an effective identity system. Okay, so suppose that your original system has impulse response h of t, and your inverse system has impulse response h sub 1 of t. Then by taking x of t, passing it first through the original system, then through the inverse system, you should get back the original input x of t. So this means that the concatenation of these two give you effectively an identity system which should have impulse response delta of t. Now, we learned before that the concatenation of two linear time invariant systems has an effective impulse response that is equal to the convolution of their respective impulse responses. So this is saying that h of t convolved with h sub 1 of t, which is the impulse response of the inverse system, should be equal to a unit delta unit impulse function. Now we can look at a couple of examples. So in this first example, we assume that the input-output relation can be described like this, right? So if you input x of t, then your output will be a time-shifted version of x of t. Okay, so this implies that this system has an impulse response that is equal to delta of t minus t naught. Okay, so with this, your output x t minus t naught will be equal to x of t convolved with this t minus t naught. Okay, so convolving your input signal with this delta of t minus t naught shifts the signal. Right, this shifts signal by time t naught. Okay, so your original system shifts the input signal by time t naught. So an inverse system, right, an inverse to this system would be a system that shifts the signal back by minus t naught. Okay, so in this case, the inverse system has impulse response h sub 1 of t that is equal to delta of t plus t naught. Okay, now you can check that this is indeed an inverse system, right, by taking the convolution between h of t and h sub 1 of t. Right, you have this delta of t minus t naught convolved with delta of t plus t naught. Okay, so this is like plugging delta of t plus t naught as x of t in this equation here, right? And the output will be this x of t minus t naught, which gives you back this delta function.